Hi class, welcome to Is451. I'm Professor Fahmi Jalani. Today we will cover chapter 9, which is an introduction to Metropolitan Area Network and WAN, Wide Area Network. So let's jump right in. As we all covered in our earlier class, LAN or local area network consists of rooms or building and offices. MAN covers more on a city-wide network. If you been to Minnesota, there are some areas where there are free Wi-Fi that you can use, for example. And also we have WAN, Wide Area Network, where there are technically multiple cities on the internet. MAN is basically supplementary of LAN and WAN. These are more for backup system, and technically most used by the authority. Most of the networks are in fiber, which is more reliable and more fast. Let's take a look at MAN. In the diagram here, we see a fiber optic networks connected between businesses. They have high speed internet, for example, connectivity, and is in a star configuration. So comparison between SONET and Ethernet MANs. The diagram here shows SONET switches and together with fiber optic. It's much more expensive. It's based on a T1 speed range from 1 megabits to 1000 megabits. Okay. And they have quite high follower time. So we take a look at the comparison here. Here we have the topology of MAN. Okay. Like we mentioned earlier, it's a combination of LAN and WAN. It's more like a spider web. Let's take a look at the Metropolitan Ethernet. Okay, the diagram here, connectivity between three businesses over the cloud network, also known as Metro Ethernet. This is basically door to door. Okay. So and it's more on a point to point connectivity. More illustration. It could also be connected to multi-point with multiple businesses. So in this case, when company A sends a packet, it will send to all the company at one time. Okay. Next we have WAN, or Wide Area Network. Used to be quite slow, okay. And it uses because of its uses of telephone switches. Okay. Also due to advancement, now it's getting much faster. Right? Here we have the station, okay, as the interfaces, and we have nodes for the transfer of data. Okay. And it could be a computer, router, or switch. Okay. types of structure we have here, for example, in the diagram we have a dedicated circuit. This is basically a private line that is connected. Also we have the circuit switch network, or you call it, okay, for the dedicated line. In this case, for example, you can have a dedicated line from the president's office to the, could be the defense office, for example. Other types of network, we have a packet switch network, where here all the data are fixed size package. I think we covered this earlier. Also we have a virtual circuit, where networks could be changed without physically but through software. Next we have broadcast network. Like we mentioned earlier in this one slide, business A can send one packet to many businesses at one time. In summary, here we see the diagram, clock characteristic. We have a circuit, datagram, virtual circuit, and broadcast, and we see the availability. Okay, yes and no. So next we take a look at the connectivity between connected and contactless. So the question that you might ask is, what the software application used for the network, for either in this case wired or wireless, yeah. Both at the sender and receiving end. Will there be any big data will be sent? Will there be any security, for example, for finance or banking? So here the next diagram we see a telephone call, for example. This is basically the steps, that the process that they will go through, okay, from ringing to hello, to introducing yourself, and to goodbye, right? So continuing, connection oriented, okay, it operates in both circuit, network, and packet, where packets are sent to either the shortest route or the fastest route. Let's take a look at routing. Like we mentioned earlier, some of the question you might ask is, so which route does the packet decide, okay, to be transmitted? So it usually will send to the nearest path, or the most efficient path, okay? And it's quite typical, as we as normal individual will find the shortest path to a destination from our Google Map, for example. Here the diagram shows 7 network with multiple routes, okay? And in this example, they are trying to go from I believe A to G, and there's several different routes. And a few things to take note. We have the cost of the route, and is there any queue in transmitting, what's the speed, and those are the things that you need to be considered. This is another example. Okay, in routing, like we mentioned earlier, it has to be optimized, and packets are treated, I would say, democratically, and the system has to be quite efficient in terms of robust. If there's any failure, packet loss, packet collision, okay, and it is able to recover the error quickly and rectify it. Some example, the figure here, they say least, what's the least cost find from one location to another. Here we see, I think this is from the first figure, A to G. So path ADG, which is 5. Then you have path ABG, which is 9. And you have path A BEG, which is 8. So here path ABDEG is the most so to say the most reliable network, and also cost efficient. Next we have flooding, where packets are technically broadcast, and due to this it's quite congested, and packets do get discarded easily. So here we example from node A, okay, from the previous example. As it reach to other nodes, A, C, D, and B, it will transmit, it will broadcast more until it reach the final destination. Next we have central routing, where the table here shows a central node. If whenever there is the need for them to route, it will refer back to this table. So when there is a failure, there is a backup, and this is basically for high traffic usage. As for distributing routing, the table also here shows, for example, for node C, okay, so it has two routing table, its own routing table, sorry, and with a global table for its reference. Let's take a look at adaptive routing. The adaptive routing is, it has its own table, but it changes to suit the efficiency and reliability. So As for static routing, the table is fixed, it can't be changed. Let's take a look at example. RIP, not rest in peace, routing information protocol. This is basically used for the first routing protocol. For example, initially was adaptive and distributed. This has formed into a vector routing. Here we have 4 network: 1, 2, 3, 2, 3, 4, 4, 5, 3, 4, 5, and 7, 8, 9, with different types of hop: 8, 5, 6, and 10. This is basically what we covered in the previous slide, the numbers. Example, so now we're supposed to hop to route D. Okay, here they mention that route D doesn't send information. Okay. Route A will look for at each entry in router D table and make the following. Okay. For example, router D will send to, say, 1, 2, 3 is hop 4 from router D. Since router D is 1 hop from router A, network 1, 2, 3 is actually 5 hop. Okay. Yeah. So the process will refer to the table. Okay. So we will cover the next network congestion. So when there is too many packet that is traveling in the network, there will be a jam or congestion. Could be nodes, traffic, poor planning, link failure, for example. When it could be connectivity failure or physical failure. And this will lead to overflow, packet loss. So how to eliminate or reduce this? Yeah. We have things like impact congestion control or explicit congestion control. Yeah. Some we have congestion avoidance. Basically, this is real time. It has to be real time for the bandwidth. So if the network has to check before establishing the connection, when it's satisfied the user, it will send. So in the event that it doesn't have to satisfy the user, it's much more cheaper and simple, or it's called connection emission control, asynchronous transfer. And lastly, we have a smartphone for WAN. This is basically cellular network that we covered initially. Signal are transmitted from the smartphone to the cellular tower and vice versa. And as you move, it changes from tower to tower. And that's where you can see the power of the bar of the internet on your mobile phone. So that's pretty much it for this chapter. If you have any question, please email me or set up an appointment. Okay, please stay safe and thank you very much. Have a good day. Bye bye.